In this video, we are going to conduct an interesting comparison between the refrigerant gases r134a and r600a. So get ready to discover the differences between them. Let's start by saying that r600a and r134a are pure gases that can be recharged in both liquid and gaseous phases, since they are not composed of gas mixtures. R600a is a hydrocarbon used as a refrigerant, mainly in domestic refrigerators. On the other hand, r134a is used in equipment of any power, such as domestic and commercial refrigerators, chillers for building air conditioning, chillers for machine cooling, and automotive air conditioning systems. The main advantage of r600a is its low environmental impact and excellent thermodynamic properties, which contribute to its increasing use. R600a does not harm the ozone layer and has a global warming potential, GWP, of 3. On the other hand, r134a also does not harm the ozone layer, but has a GWP of 1430, which, over the years, is starting to face challenges with stricter environmental regulations. R600a, isobutane, has a safety classification of A3, non-toxic but flammable. R134a is non-toxic and non-flammable. Although R600a, isobutane, is flammable, its use in refrigeration systems, with lower cooling capacity, reduces the risk due to the significantly low amount of R600a refrigerant used. Isobutane R600a, like other hydrocarbon refrigerants, generally has good miscibility with any type of lubricant, although in many cases, it is recommended to use oils with higher viscosity. R134a is compatible with PO oil in conventional refrigeration and POG oil in automotive air conditioning. On the screen, we have the tables of capillary sizes for R600a and R134a for the same cooling capacity. R600a has proven to reduce the energy consumption of refrigeration systems compared to R134a. R600a and R134a are not direct substitutes for each other in equipment that has already been used, unless authorized by the manufacturer. However, if R600a is replaced by R134a, the capillary must be changed, because the displacement of the compressor with R600a is higher than with R134a. Now, let's study in detail the specific pressures of each of these refrigerant gases, where we will observe that the pressures of R600a are very low, even reaching vacuum pressures in low temperature applications.
The most used r134a refrigerant gas pressures are 1. To reach a temperature of -20 degrees Celsius in the evaporator, equivalent to -4 degrees Fahrenheit. A low gauge pressure of 0.32 bars is required, equivalent to 4.70 Cg or 32 kilopascals. To achieve a temperature of -15 degrees Celsius in the evaporator, equivalent to 5 degrees Fahrenheit, a low gauge pressure of 0.63 bars is needed, equivalent to 9.26 psig or 63 kilopascals. To reach a temperature of -10 degrees Celsius in the evaporator, equivalent to 14 degrees Fahrenheit, a low gauge pressure of 1 bar is needed, equivalent to 14.70 psig or 100 kilopascals. In some cases it is useful to know the pressure of the equipment when it is turned off in the high pressure or the condenser. Let's go see them. For an outdoor environment temperature of 30 degrees C, the equipment turned off at this temperature has a manometric pressure, both high and low, according to the table of 6.70 bar, equivalent to 98.49 psig or 670 kilopascals. For an outdoor environment temperature of 30 degrees Celsius, the condenser temperature is usually about 10 degrees Celsius above the environment where the equipment is located. Thus in the table for 40 degrees Celsius, about 104 degrees Fahrenheit. The high gauge pressure in the condenser is 9.18 bar, equivalent to 134.94 psig or 918 kilopascals. Equivalent to 134.94 psig or 918 kPa.
On the screen we have a pressure gauge specially designed to work with r600a refrigerant gas. Remember that this gas works with quite low pressures compared to other refrigerants. The pressure values for r600a are values below atmospheric pressure. As the values of the manometer are calibrated to mark 0 when it is exposed to the pressure of the environment, the pressures that r600a will have are negative because it has a pressure below the atmosphere. As it is difficult to have a precise measurement for such small pressure values, it is highly recommended to work with r600a only with special manometers for this gas. This manometer clearly brings the temperature scale together with the depression in a very simple way. Thus, for example, for a low temperature of -10 degrees Celsius, we only have to wait for the needle to stop, with the equipment turned on at the value of -10 degrees Celsius. In this way the following pressure value is obtained. In addition to using the appropriate pressure gauge, r600a refrigerant gas charging must be carried out, so the appropriate pressure gauge must be used to make the needle pressure heat stop. The value of the needle pressure should be taken into account that the pressure of the needle pressure stops, and the pressure of the needle stops. The needle pressure value must be taken into account that the needle pressure stops. In addition to using the appropriate pressure gauge, the r600a refrigerant gas charge must be carried out by weight, thus reducing the chances of error. r600a can be charged in both the liquid and vapor phases. Now we are going to verify what will be the value of the high pressure. For an environment of 20 degrees Celsius, we are going to have an average condensing temperature of about 30 degrees Celsius. Now let's set the needle to 30 degrees Celsius and note the pressure value. If we want to know the pressure that the equipment should have being turned off, we are going to search the manometer for the value of the ambient temperature. That is, we place the needle at 20 degrees Celsius, and thus we can read the pressure value.